All right, so we are going to have our little matching experiment here. All right, so I can't help but notice we have a whole bunch of standard form expressions that we're trying to graph. And it's kind of tough to do that. So to graph a standard form expression. So what I'm going to do is I'm going to turn the standard form expression into slope-intercept and then match from there. All right. So, and I can't, before I go on further, I can't help but notice that some of these graphs all look pretty similar. So I may have to worry about the shading, especially for these two here, because notice how the shading is very similar. And the boundary lines are the same. Do I have any other boundary lines that are identical? Doesn't look like it. All right, so here we go. So I'm going to subtract 3x from both sides. And I'm going to get y is greater than or equal to 6 minus 3x. All right, so I have a y-intercept of 6 and a slope of negative 3. So which equation or which graphs have a y-intercept of 6 and a negative slope? Well, C has a y-intercept of 6 and a negative slope, so there we go.
That was easy.
All right. So then, for our next one, we are going to subtract x minus x. So I get negative 3y is greater than or equal to 6 minus x. Notice how I didn't drop that negative, so divide by negative 3. And when I divide by negative, I have to flip the sign. So I get y is less than or equal to, that's a negative 2. Negative by a negative is a positive, so that is a positive 1/3 x. So where do I have a y-intercept of negative 2 and a slope of 1/3? Well, here's a y-intercept of negative 2 and a positive slope. All right, and y has to be less than, so it's shaded below. Okay, you may have noticed that in our work so far, that there's a shortcut to finding the shading. So now minus 3x, and I get y is less than or equal to 6 minus 3x. So we have a y-intercept of 6, but now a negative slope. No way. But wait a second. Oh, I see trouble in paradise, folks. Oh boy, because if I put this here, notice how we also have a y-intercept of 6 and a negative slope. But these two signs are not the same, are they? So I do have to worry about the shading. Okay, so this one says y is greater than, and this one says y is less than. So it has to be one of these two. One of these two. So let's plug in a point. Let's plug in 0, 0. That's not what I meant to do. 0, 0. All right, so if I plug in 0 is greater than or equal to, oh, that's 0, 6, this is false. Oh, no. So that means 1 does not match, does it? Number 3 has to match. Oh, boy. Well, I knew that might have been a possibility since we have 9 equations and only 4 graphs. All right. So then, let's move on to the next one.
Do you know anything about Midsummer?
Apparently, we're having troubles finding Midsummer Night's Dream books. I was asked, what do I know about them? All I know is I don't want to read them. All right. So, our next problem, we are going to subtract x. Feel more red right now. So we get 3y is less than or equal to 6 minus x.
Okay. Thank you.
All right, no worries. All right, so then divide by 3, divide by 3, divide by 3, and so I get y is less than or equal to 2 minus 1/3 x. All right, so y-intercept of 2, slope of negative 1/3. Oh, okay. So right here we have a slope, y-intercept of 2, and a slope of negative 1/3. Now I don't, well, and let's double check, y is less than, okay, so that's going to be under the line. Okay, we're good. All right, getting a little concerned after our first debacle, right? So then subtract x from both sides. So I get 3y, negative 3y is less than or equal to 6 minus x. Let's divide by negative 3, divide by negative 3, and I get y is less than or equal to negative 2 plus 1/3 x. But, oh, geez, if I divide by a negative, I gotta flip the sign. I bet you thought I was going to say a different word, didn't you? This is a G video. All right, so we have a y-intercept of negative 2 and a slope of positive 1/3. It's the same stinking, no, it's not the same equation. Oh my goodness gracious, look. It's the same thing except the signs are flipped. Okay, so we know how to deal with this. This one says that y is less than. And so the shading is below the line. Okay, so I know that's good. And I can plug in 0, 0, and 0 is less than or equal to negative 2. That gives me a false statement. So therefore, I wouldn't shade towards 0, 0. So, okay, so we know that works, and we know this one does not. Oh man, this is getting trickier than I thought it would be. All right. Thankfully, this one is not in standard form. None of the other ones are too. That's nice. So y is equal to negative 3x. My y-intercept is 0. My slope is going down. Okay, so that's both of these, all right. And y is greater than. So that means if I can't plug in 0, 0, but I can plug in 1, 1. So I'm going to plug in 1, 1 right here. So I get 1 is greater than or equal to negative 3. That is a true statement. So that means that this expression here I'll put it right here. All right. Which also means that this one's got to go here. All right. And then x is greater than negative 3. It's right here. Because everything above, or look greater than negative 3, is shaded here. And for my last one, we have y is greater than negative 3. That's this one here. All right, so let's double check. Oh, we do, oh look. This does have a y-intercept of 6, and it's going up by 3. All right. So where do I have that? Well, here it's going down by 3. No, that doesn't work. And then over here, we have x has a y-intercept of negative 2. And the only y, these are the only two with a negative 2. All right, so here's what I've learned about connected math. I think there's a typo in the connected math book. Or maybe I made a mistake. So for this one, oh geez, what's the opposite of subtracting? It's adding. That's embarrassing. So this would be positive. So this one does match with this. Oh, geez. I'm sure you noticed that right from the beginning. Well, but you're much more smarter than I am, so that's probably an okay thing. All right, so then moving on to my last question. Okay, consider the inequality y is less than 3x plus 6. Well, what is the big difference here? The big difference is we have a dashed line. This is an open line, which means that y cannot equal, that's the cannot equal sign, 3x plus 6. So this is still a boundary line. It's saying that at this point, the shading is going to end because everything on this side is not going to satisfy the inequality. But everything on this side will satisfy the inequality. So for the open line, we're going to be using the less than symbol or the greater than symbol. All right, I hope you enjoyed that video. And if you have any questions, please show up to the help session.
That was easy.